Hey there! In this video, I'll share with you an effective method to write net ionic equations. I'm Orlando Broomfield from Chemistry Core. Let's solve this chemistry exam style question together. After rewriting this word equation as a balanced chemical equation, we will then use 3 steps to set out the solution for the net ionic equation. You may know this kind of reaction as a double substitution or a double decomposition reaction, but it's also known as an ionic precipitation reaction. That is because the reactants are ionic compounds and they are exchanging radicals to form 2 products, where one of the products is not able to dissolve in aqueous solution. We know the solubility of these compounds because of the solubility rules, which state that whenever a compound has the nitrate ion in it, or ions from group 1 elements, those compounds are always soluble without exception. But when a compound has the halides, that is, chlorides, bromides, iodides, then those compounds are soluble except if those compounds also have barium or lead. So we know that lead 2 chloride is insoluble in aqueous solution, and we will use S to represent that insolubility. Potassium nitrate, of course, we need to put the AQ symbol to illustrate that it is soluble in aqueous solution. To write the balanced chemical equation, we need to transform these compounds from words to chemical formulae. And to do so, we need to know something about the charges of the cations and the anions in these compounds. Let's start with lead 2 nitrate. Lead is a transition metal, and this Roman numeral 2 indicates that in this compound, lead has a charge of 2+. The term transition means that these metals can exist in various oxidation states, or they can have different charges when they appear in compounds. The nitrate is a polyatomic monovalent anion, written like this: NO3 with a single negative sign. Potassium has a charge of +1, and the chloride ion will have a charge of -1. Potassium has a charge of +1 because these atoms will lose their only valence electron to become stable, thereby obtaining a charge of +1. And the chloride ions will have a negative charge because they would have gained a single electron to obtain stability. Again, we put Pb 2+ because of this Roman numeral here, telling us that the charge on lead in this compound is 2+, and we know what the chloride ion is based on the chloride ion here. It's the same, and we just write K+ for potassium and NO3- for the nitrate polyatomic anion. How do we then move from ions to compounds? Well, we need to transfer or exchange the number of the charge for each ion and rewrite that as a subscript for the other ion in the compound. So the 2 from the lead will go to the nitrate group, and the 1 not written but understood will go to the lead. And that gives us a formula Pb, and there are 2 nitrate groups. Now, because we have more than 1 atom, polyatomic anion, right? More than 1 atoms in the anion, we need to put a bracket around the polyatomic anion and then the 2 subscript to show that there are 2 of the anions in the compound, and the 2, remember, it is coming from the lead here. For the potassium chloride, we simply rewrite them as is. Why? Because there is a 1 coming from the potassium cation, a 1 coming from the chloride ion, and we do not write 1 because the ones are understood. Then for our lead 2 chloride, we put the lead, and there's only 1 ion of lead because the 1 from the chloride ion is coming over to the lead, the 2 from the lead is going over to the chloride ion. And we do not need a bracket around the chloride ions because only 1 element, 1 kind of element, is in the ion. And lastly, for the potassium nitrate, a 1 is coming from the potassium and a 1 is coming from the nitrate polyatomic anion, and we rewrite the formula with the ions with no change. Let's put our plus sign on the left hand side, which means reacts with, and the plus sign on the right hand side, which means and. It's now time for us to balance the chemical equation, which means we are to ensure that on both sides of the equation we have equal amounts of each atom. Now, we can only do so by adding coefficients if necessary. Let's start with lead. There is only 1 lead on the left hand side and 1 on the right, so that's balanced. Let's now check our nitrate group. There are 2 of them on the left, only 1 on the right, therefore we add a coefficient of 2 in front of the potassium nitrate to give us our 2 nitrate groups on the right. That's now balanced, but this 2 affects the potassium. Now we have 2 potassium on the right and 1 on the left. We need a 2 in front of the potassium chloride to balance the amount of potassium in the equation. Lastly, we need to check our chloride ions. On the left hand side, we have 2. On the right hand side, we also have 2. So our equation is now balanced. The only thing left is for us to include our state symbols. Remember, from here, all nitrates are soluble without exception. So we can go right ahead and put AQ, the symbol for aqueous, meaning they can dissolve in aqueous solution. All potassium compounds are also soluble, so aqueous again. And now for our chlorides. Chlorides, bromides, iodides, based on the solubility rule, are soluble except for barium and lead. So we put an S here to indicate that lead 2 chloride is insoluble in aqueous solution. We're now ready to do our first step for writing the net ionic equation. In the first step, we separate all the aqueous substances into ions, And in doing so, we write an ionic equation. So let's separate lead 2 nitrate into its respective ions. We will have Pb2 plus aqueous plus 2NO3 minus aqueous plus 2K plus aqueous, and we are separating potassium chloride because it is aqueous, plus 2Cl minus aqueous, going to form, we do not separate lead to chloride because it is not aqueous. We only separate the aqueous compounds. Plus, and we separate the potassium nitrate into 2K plus aqueous plus 2NO3 minus aqueous. It's time for our second step, and that is to eliminate spectator ions, ions that did not take part in the chemical reaction. A spectator ion is an ion that did not change as it moved from reactant to product. So we look for three things when we are deciding if a change occurred. So if there is no change in the ion's charge, the number of the ions, and the state of the ion, then that ion is a spectator ion. So let's see which of these ions is a spectator ion with no change in charge, number, and state. Let's check our lead. We have aqueous on the left hand side and solid on the right. That means the lead is not a spectator ion. Let's check our nitrate. We have aqueous on the left, aqueous on the right. We have 2 and 2, so the number hasn't changed either. And we have a charge of negative and negative, -1 that is. So our nitrate ions are spectator ions. Now let's check our potassium. We have 2 and 2, +1, +1, aqueous, aqueous. The potassium ions need to be eliminated because they are spectator ions. And now for the last ion, the chloride ion. Right away we can see that there has been a change in state. On the left it's aqueous, on the right it is a solid. Therefore, the chloride ions are not spectator ions and they do not get eliminated. And now for our final step, where we rewrite the chemical equation with all the ions that have not been eliminated because they were not spectator ions. They were involved in the chemical reaction. So we are left with lead Pb2 plus aqueous plus 2 chloride ions aqueous going to form the lead 2 chloride precipitate. Thank you for watching another video on solving problems in chemistry with Chemistry Core. If you were tuned in, you are now able to write an ionic equation and eliminate spectator ions to rewrite the equation as a net ionic equation. Good luck on your exams, and I'll see you next time.